I think you guys need to share the screen if you switch to StreamYard. One in the middle. Like that. I think you're ready to start.
Click the view and
Professor, there's a couple of videos that we have in our presentation here. You don't have permission to play them. Try to sign in to Google and then present it from Google Drive.
you just go to the video that's like that live in the middle.
Yeah, go ahead.
Oh, yeah, it's not Professor.
Do that.
I don't know how to get around this.
Oh, it's like when you posted your drive, you have to. I bet if you go into your Drive account where you stored it, link it to the thing.
Is the video just in your Drive account?
Yeah, but we allowed it to be viewed by other people. But,
No, I didn't know that. Thank you.
Because I know you have to link it to get it. That's just my.
That would make sense, yeah.
So the progress we made this week where we finished simulations for the toolpaths, and we got all the hardware we need and some of our stock we're gonna be using. And the goals we have for next week are to machine around 3 to 5 of our parts. We're aiming to get all the body parts done so we can at least assemble the big body part of it. Problems and challenges we expect are finding time in the machine shop to get all this done. But we're going to be working with Hayden on Friday to help us machine the parts to make it go a little more smoothly. And scheduling tab again. This week we're in the machine parts section and nothing else new with that one. Again, what stocks we need. Hardware again from last week. With and this is the floor of the body piece being machined, and the tools we're going to be needing are the 3-inch face mill, contouring with 3/8 end mill, 1/4-inch drill mill, and pocketing with the 3/8 end mill. Again, the video is only one of the steps because I was working with one of the lab assistants. They were saying do it in 3 steps. So what's up here flip it around, get the other side of excess material, flip it on its side, and then get the hole. So only have just that one video, but all the steps all completed.
Yeah, so this one's the handlebar piece. Similar operations, 3-inch face mill, contouring with a 3/8 end mill, and then drilling with the 1/4 inch drill mill. Again, this is also one of the faces, just so we can show that this is one side, but we're gonna flip it over, and it's gonna be the same operations on the other side. This is the handle end, also very similar, facing with 3-inch, contouring with 3/8, drilling with 1/4 inch, and then pocketing with 3/8 to make one of the larger holes. And yeah, again, it's also only on one side. You can do the same to the other side, just to show for the video right now. And this is the piece that connects the handle to the body itself for kind of crushing the can. This one's a sliding jaw. This is actually the thing that's going to be crushing the can. I believe this was the same toolpath that was shown last week. I know there was some comments on it, so those were fixed. And this is, again, just one of those sides. This is already a stock that was imported because from a previous step, so that's why there's those holes on the sides. This would be, I believe, step 3. Step 4 would also be flipping it over and doing the same thing on the other side. But essentially, it does the contouring or the facing with 3 inches, 3-inch face mill, contouring with the 3/8, and a pocket with 3/8 as well.
The operation it's doing right now is concentric in.
Yeah, that's what.
Change that to concentric out. Might be
Out?
another operation.
Okay. Is there a reason why I prefer it? Because when we were doing it.
It'll spend less time fully engaged if you do the concentric out.
Okay.
It'll just make one slot in the middle and then it'll work its way out.
Okay.
Or you might look at one of the profit milling toolpath options.
Okay.
I don't think it would crash.
Okay.
I think it would sound nicer if you did the other path. And it feels better to me to start in the middle and work my way out when it's a piece like that.
Okay. Awesome.
That might be the only reason I say it, actually, is because it feels better to me.
I mean, either way, I think it should get the job done. But it's not that hard to change anyway. Just go in and change it to concentric out. But yeah, for the next steps, yeah, order the remaining stock material. We have some on hand already. And then I guess finalize any design changes, but so far I don't think we're doing any more changes. And then hopefully machine 3 to 5 parts so we can start assembling next week. And yeah, we're going to be in the lab tomorrow because we found out that a lot of our time for us that we can meet together is Fridays usually. And last week we were working on the Esprit. So hopefully this week tomorrow we're in the machine shop. At least like 2 or 3 of us to try and get some of the parts done. But even if it's just like one for now. But any questions?
You guys have any questions from the class?
On that first simulation you showed, I was just curious how you planned the fixture of that.
Oh, you stole my question.
We plan to what?
How are you going to hold that when you do the facing operation?
Was planning on using clamps was the suggestion, and it said so.
Pause the video. Oop. There, pause here. Could you
Go back to
show
the
us
facing
where you're going to put the clamps?
Like in the center there and over on the right side on like the bottom half of the section, since it doesn't.
So you're going to push this way on the part.
Yes.
Okay. So when you do that 3-inch face mill, the majority of the cutting force is up.
Okay.
So if you've got a couple of little things up against it, like a Mighty Bite or something like that can hold it sideways like that, it's going to pull up out of there with that 3-inch face mill. I would use a smaller tool. You keep the cutting force down. And also, if you just do the smaller tool and keep the cutting force down, so finish the simulation. Let's watch the whole thing. So what's the thickness of the stock material? Do you know?
Like
Should be 7/16.
yeah, 7/18, 7/16.
So that's 8/16 is a half, so just under a half.
Yes.
So you're probably not going to find 7/16 stock.
Yes.
You're probably going to get half-inch stock then.
There was on McMaster, I think we saw there was 7/16, but it's easier to get half than it
Yeah.
is.
I don't know what the delivery time is on it. I don't know what the cost is. Half is much more common. I think you've missed how you're going to fixture this, because the way you describe it isn't going to work to make this part, and you have to make a fixture plate to do that.
Okay.
So you have to make another part in order to fixture it the way you described. Typically, with a plate part like this, you clamp it, but you clamp it down, so the body of the clamp is on top of the stock material. And so if you clamped it down, you could still make this part. You would just have to have a tool path that didn't interfere with the clamps.
Yeah. Okay.
So if you could imagine, I'm gonna fuck it up. Try to do this without breaking my computer or spilling my coffee. So if you could imagine you had a clamp down on this corner, on this corner, on this corner, and on this corner, and you were holding the part down to a surface. Now you're making this pocket that goes all the way through, right? So you want to put like a sacrificial plate underneath it. Sometimes we even use like a piece of wood or something, just put it underneath it to lift it up off the machine tool bed so you don't cut the machine tool. But if you get a clamp here and a clamp here, clamp here, and clamp here, you could then do a facing operation with a smaller tool, like a 1/2 inch end mill or something. And you can face this part to make it the thickness you want, right? You could cut this pocket out, that's all no problem. You could cut around it with a contour that does a slot that cuts around the part, and use this part disconnected from the two pieces you have clamped down.
Okay.
You could do that. What's the problem with that, somebody in the class?
Cutting off parts. Or
Doing that last slotting operation that basically drops this middle part out, it works perfectly if you have the right feeds and speeds, right up until the part's no longer connected. And so as you get to the end of that tool path, eventually the cutting force you're applying to the part is more than the strength of the material that's left. And it breaks. And when it breaks, it moves. Right? You can imagine that because you're still pushing on it when it breaks. And when it moves, like it's something like this, it's like it's bouncing around inside a contained thing. So it'll spin around and then bang into the tool and you'll chip the flutes on the tool. So to do that, clamp it here, 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 and here so that when it cuts off, it doesn't move. Good. And would you need, is it just the right length? Does your tool path go around the back?
No.
If it did, what you would do is do like part of the tool path, move the clamp to the part that's already cut, and then do the rest of the tool path. So program it as two different operations. So you can actually cut that part out. It doesn't fly around, doesn't drop out and break anything. Yeah.
could you cut the slot first and like put a bolt into the washer?
Absolutely, you could do that too, right? So you do your 4 clamps, or maybe 2 on one side, 1 on the other side, 3 clamps, whatever it is. Hold it down, do the facing, do the slot, and then if you set it up right so that slot is above a T-slot, then you put a T-nut in the T-slot, you put a bolt and a washer to hold this down, and then you cut it. So with this part, that would work. So just think about how you're going to hold it. I would not use the face mill on any of the parts.
Should we just do like a half day?
And the last one you showed, the blocky kind of part, I think it worked fine on there. I would just use the 1/2 inch ML for all those facing operations. It keeps the cutting force down. If at 1/2 inch thick, the face mill probably would make an okay part there. If it was a thinner part, like a 1/4 inch thick or something like that, even if you're holding it down well with the face mill, what's going to happen is it's going to pull it up as you're cutting on it. It's going to tend to vibrate the piece. You get a lot of chatter marks on the top of that part if you use a face mill to do that operation. I can say this with confidence because of years of experience having tried to do stuff like that. So learn from my mistakes. I've made a lot of crappy looking parts by using a face mill to try to do something like that. But so you get holes in the side of your part, right?
Yes.
And so the plan is to make this operation, then you're gonna turn it on and then you're gonna drill that hole.
Yes.
And then some, like a pin goes between them, and then that's what the handle rotates on at that spot. That'll probably work. You're gonna have to do the hole for both sides. You're not gonna make a hole that goes all the way through, probably.
And when you want to do that first, also before you do the pocketing, just so it doesn't like kind of.
Well, if you did it before you did the pocketing, that would be better. But then what I would do would be make the part the right width first, right? So if you make the part the right width before you even do this kind of an operation, then you don't ever have that contouring part around the outside. You don't have that problem. Then put it on its side, drill all the way through. What's the distance?
Like 3 inches by 8 inches roughly.
So 3 inches deep with that hole.
Oh, it's like
Yeah,
3 inches
when it's, but when it's on its end, that's 3 inches down. In order to make that hole, that edge space has to be pointed up, right? So that would be down in that orientation. That's why I said it. So when you think of it like that, 3 inches deep. What's the diameter of the hole?
a quarter inch.
I think so.
It's a clearance hole for the. You're using just like a.
Should be something, so.
So it's not going to be a press fit or bearings or anything like that.
That's not very, very, I think so.
Oh, we're about to drill walking out.
Yeah.
Quarter inch drill at 3 inches deep might walk out and maybe in the center of the part on one side, but it won't be in the center of the part on the other side. Drill for both sides. Then you just have to worry about whether or not you probed it right and lined it up right.
How long
Just
are the
clear.
drill bits?
What's that?
How long are the drill bits? Like
You can buy them any length you want.
the ones that we had.
I don't know. I haven't measured the flute length on the quarter inch drill. Probably not 3 inches though. Maybe 3 inches.
Are they on the? Is it on the? What's it called? The MFE website.
No, but you can Google standard length for quarter inch drill, and they're all about the same length. Or you can go in the shop and pick one out of the drawer and measure it, which is what I would do. But I think I would drill the hole for both sides. And I don't often say that, but I think I would drill this hole for both sides.
Okay.
And then you do it before or after, doesn't matter.
Okay.
Anything else from the class? All right. Group dose. Good. I'm learning Spanish. Grupe dose.
No, I'm going.
I made Spanish waffles this morning.
What makes them Spanish?
I counted in Spanish when I was making them. Uno dos.
Where do we get the?
That one. Yeah. Go upper right hand side group. Yeah,
On the left.
that'll work.
Oh, yeah.
I think that's right, isn't it?
Yeah. The drop down, it's like it's either group.
No, it's so good. Where?
We're both putting them side by side of the screen. Yeah.
What? Oh, okay, sorry.
You don't have permission to view your videos either. So
Just
you
one
have
of
to log
you
in.
sign in.
Just one of them. Let's find out which
Just
one.
sign
it
into
is.
Google.
Yeah, if one of you signs in, it'll get shared with the whole team.
Okay. And I've got it. Okay, so this week we met in the machine shop on Thursday and machined the pond, which here we have the E-Spirit operations done on almost all the parts, just the rook and the I got it, right left. You can see, you can talk a little bit about the experience of machining the pond.
Yeah, I'll talk about it.
Okay. But next week we want to finish up with the last two spree things, simulations, and then get the part parts that we have done machined and start working on the ones that we have not. Setting up tooling is a consideration for that. And then apparently the brass stock has gone missing.
Hasn't arrived yet.
Oh, okay.
And then we're also still waiting on a 1610 mil for our clean.
So we can start looking at the simulations.
Here's the clean simulation.
I think we've already shown this one. This one's a minute long. I can make it go a little faster.
So it does the roughing, and then it does the contour, and then we use the tiny little.
That's the part being done with the milling operation for the slots in the top of the turret.
Cuts it off.
Cuts it off. Next we have the king, which
Very
is
similar.
but without the milling operation, because I believe it is still radial as symmetrical. Again. Oh, no, there it is. We've added the, I believe that's the bit we're waiting for. And then,
The pawn is the simplest piece we made. Took about 40 seconds of cutting to do. So it's a simple facing and a roughing, contour and cut off. All with the lathe parts, or the lathe bits.
we didn't run into any issues while running it, other than that the truck jaws were a little off-centered, so the end piece came up looking a little.
Yeah, if you look at it closely, you can see one half of it is, it looks like it was only roughed, and the other half is nice and smooth and finished.
So that indicates the part became uncentered in the middle of the operation.
Right.
Not that the chuck jaws were uncentered.
Okay.
So that means your part moved while it was being cut.
Yeah.
So they may not have been clamping tight
Oh
enough.
yeah, that's what I meant. It wasn't.
Yeah, so you may not have been clamping tight enough.
Yeah.
You didn't crash in between the operations or anything,
No.
because that'll move the part.
Yeah.
I've seen that happen.
Yeah.
I would be concerned. Do you know what your max spindle speed was?
30 something, 32.
Yeah, I'm guessing that when it spun up that fast, that the centripetal force on the chuck jaws pulled them apart, and you were no longer clamping tightly enough on the part, and it moved slightly in the jaws from the cutting force. And then when it did the next operation, it wasn't in the same place.
Okay.
Right. So you can, because that's a really big chuck, and the chuck jaws are really heavy on that. If you slow down, it'll have less separation. Also, somebody may have reduced the hydraulic clamping force on the chuck before the previous person may have been cutting something like plastic or something and turned that clamping force way down.
Okay.
So have somebody show you how to adjust the clamping force and check that too. But I think I would slow down, and also I wouldn't spin that fast.
Just make, because that's gonna be an issue with all of
If
the
you,
parts.
yeah, well, in a spree, you can, on each operation, you can set a maximum spindle speed and set it to like 2,000, 1,500 or 2,000.
Okay.
It won't get you the most efficient cutting operation, but it'll have less risk of those chuck jaws flying out.
Okay. And then here's the bishop simulation. You can slow that down, but
Pretty simple.
pretty simple. I'm gonna change it to add contours. I mean, to add fillets on the edges so that it isn't really sharp. And then, you want to talk about the S5C?
Yeah, this just helps helps with the 3-axis, almost acts as a 4-axis to a mill machine. Who put this? I don't even know. Do this.
This just helps with, this is just like
Thanks,
another thing that could help with, like the clean of the rug, because it, rotates the part equal increments for like a milling operation.
Okay.
So like that, it would rotate the part instead of like what we're using. So we just thought we should like include it, because it's like another way to, instead of using the bar or like
Yeah.
the mill turn machine, you could have used this. So we're not using that.
Thanks, Chris.
So, any questions? We're planning on finishing machining each of the parts, and then just use a test run, and then doing it all on a line using the bar feeder once we've got them running.
We also played with the idea of doing like a board as well. We came up with a couple designs for that, but we don't even know if we're gonna do it yet or how we're going to do it.
If you're gonna do a board, you could take a piece of plywood and just laser cut some
That's
squares.
what we were thinking. Either like laser cutting something, we could even 3D print something if we wanted to. We were just concerned, like if we're gonna do a whole other milling operation, like we'd have to get that sort it out, use a different machine, and set that up, and get stock for it. So the laser might be a better idea.
Yeah, you could just like have it engrave the squares, so then you have darker and lighter areas.
Right.
Anything else?
Any other questions from the class? So can you go back to was it the Bishop? Or the simulation again? We were looking at this part together the other day.
Yeah.
And so what are, and I don't know, maybe you can hit full screen so we can zoom in. Maybe you can hit full screen so we can zoom in, maybe you can't.
If I open it.
Nice. There it goes.
All right, pause, or just explain to the class what the complications, what was difficult about this part, and what you struggled with, we were talking about the other day.
The difficulty was that I was trying to cut out some more curves into it, and the mill bit couldn't perform the contouring operation because it didn't actually fit into the intersection of the rounded part and the angled like flange of the Bishop, and it wasn't able to perform this operation, so I had to cut them out, and so I had to finish this up. With that, I'm going to actually redo the physical SolidWorks file so that there's a greater angle, so that the tool bit can fit inside of there, and actually you can notice the angle right here. This was supposed to be more rounded as this comes down.
Yeah, so what he's talking about, remind me to keep the cover on the pen, okay? What he's talking about is, so you've got the geometry of the tool right here, right? And so this is a 2-scale representation of what's going to be cut. And so if this shape cannot fit inside the shape that you drew, what the software is going to try to do, what the lathe is going to try to do, is get it as close as it can. And so sometimes when you did operations with the tool that didn't fit inside, you tried a bunch of different tools, right?
Yeah.
They did a bunch of different operations. Sometimes you would make the chain that you wanted, but the backside of the tool would wipe out one of the features you already created. Right, so that's something you're always gonna have to consider. And whether it's milling or turning, does the tool I'm using fit inside the operation I'm doing without hitting something else? Yeah, you had a question?
Would you just swap it between like a left facing tool and a right facing tool to just go.
So you could do some of the operations by reversing the angle that the tool is in the machine, right? You could do that and even cut the other direction. You can cut either direction, but we usually have this end of the tool move forward for whatever reason. So you could do that, but then still, if the geometry is complex enough, you just can't fit it in that shape. So it's something to consider when you're designing, especially when you're designing small, intricate parts like this. Now, what's the best thing about this particular project? Yeah.
There's like no customer to tell us the part we made is wrong.
Until you ship the part to the customer doesn't know what the part looks like. So it's all artistic, poetic license, I guess, at this point. That's why I keep telling these guys that they had a great project just because nobody knows what the part's supposed to look like.
Yeah. But I think that's it if there's no further questions.
All right, so we're group 3 and we're doing the hand car. So this week we 3D printed the frame, did the Esprit files for the gears, the links, the lever, which is the handle, the axles, and the wheels. Again, we redid some of the parts. Some problems and challenges we had was that not all of us are proficient with Esprit, or some of us hadn't even used it at all. So there's a little bit of a learning curve there. The 3D print bed wasn't big enough to print our frame as it was, so we had to split it in half and use pegs so that we can put it back together. That's why it's 2 colors. Some goals for next week: we're going to continue to wire EDM parts. Actually, we have some time set aside tomorrow to do that. We're going to assemble the frame once we have the parts that we can put inside, and then some assistance we'll get to later in the presentation. So like I said, we cut the SolidWorks file for the bed, or Fusion file for the bed, in half, or the base in half, and then 3D printed 2 components, and now they fit together. We updated the wheel operation, so we reduced the tapered section. So what I meant by that is the length along the axis of the taper, as well as the angle of the taper. And we resized the axle just based off the stock that we had available to us. So the contrast is terrible, but that's the gear operation for EDM. You can see it on here, I don't know. Anyways, the crank has been separated from the gear, which I'll show in the next slide, but basically we redesigned it a little bit to allow for the crank to make a full revolution without interfering with the link. And I can show that here. Can you see the mouse? Yeah. So this is the crank right here. And as you turn this lever, this link goes right through the crank. And we had to come up with a way to make this side of the crank mate with this side of the crank without anything going through it, so that the link could still travel through it. So right now what we're having is this side of the link on the EDM, this side of the link on the EDM, a pin through here, and then 2 separate axles on either side, both connected with their own D shafts to each side of the gear.
All right, so progress this week. The small gear NC code is completed along with the D shaft hole chain for the interior cut. This operation will be done tomorrow. So what you see here, these are our various wire EDM components. And we might come back and build this interior, but we're not sure if we have time yet, so we'll figure that out. And we think that we're gonna drill press all of the interior holes, because we think it would be probably the easiest way to go about it.
So, touching more on this, how this operation is going to end up going is we're going to mill out, first of all, either on a drill press or on a regular mill. We're going to mill out a center hole that acts, as you can see here for these two, acts as the center, the origin for a lot of our parts. And that origin is going to be used for both programs, which are going to be done concurrently, or coincidentally. So, starting off with the actual shaft hole itself, that's going to be wire EDM'd. Then we're going to move the EDM outside of the part in order to complete both gears from 7 pieces of metal. So how it'll go is origin the part off of the center hole that we drill, do this, and then we get a new part. Then we repeat the exact same thing with the origin, and then this and this.
All right, so more progress this week. The axle operation. Initially, we planned on bonding the small gear to the axle, but we've decided to use a D shaft because we realized that welding this gear to the actual axle would be kind of challenging. So we're just going to use a D shaft for most of the axles. And then now the lever operation. This little lever linkage was completed. Now we just have to drill the 2 holes on either side. And the geometry of the lever was altered to a more planar style to allow a singular pass on the EDM. That was for the last game.
Yeah.
Link for the drive gear is not ready for drilling. Still deciding on the pin diameter, so we have not drilled yet. Opinions are welcome for hole centering as well.
Yeah, so some difficulties that we're still having are figuring out, obviously it's getting down to crunch time with both MQPs and this class. So reserving and then using the wire EDM has been kind of challenging, or could have been kind of challenging depending on how yesterday went. And then also like just learning the wire EDM or EDM in general. Obviously, since it's broken from some other team, it can be very difficult even if you know what you're doing. So
Throw some other team under the bus.
yeah.
Couldn't have been us. We didn't break it. Must have been someone else.
That was the second time we slid that into the presentation.
I noticed.
Yeah. We really had to harp on that. So luckily, we made some notes ourselves during the wire EDM presentation. So we had a point of reference, and that we'd be happy to share in a discussion post perhaps. And also being able to just do it at one point. We obviously made stupid mistakes. We forgot how to clamp down the actual part itself. We forgot to use toe clamps. So that was kind of fun to bring up to Hayden. Probably the easiest issue he's had to deal with all week. And regardless, we're way more confident in the wire EDM now. So hopefully, once it's back up and running, we should be able to get a lot more parts through and a lot more done.
All right, and then goals for next week. We plan to manufacture. Well, so we have the wheel stock, and we just need to upload the program and run it. And then the solid wire esprit is ready, and the axle stock is acquired. We looked in Washburn and found that stock, and we're trying to assemble if possible and test it.
That concludes the presentation. Anybody have any questions? Yes.
Would you consider adding any sort of like brackets to help hold the 2 halves of the base together? The pegs look like they might.
Yeah, so I think I'm gonna go back and 3D print some sort of supports and try to epoxy the 2 sides together and kind of brace it. As you know, when you're 3D modeling something, it just looks much better than it actually comes out. So I'm gonna go back and fix that so it's nice and supported. Yeah.
Should you move on to the progress?
This one?
Yeah. How does that shaft fit inside the gear?
The bottom right.
Good
So-
questions.
Go ahead.
Okay. So this model isn't really representative of the actual part itself. It was representative of our original model. So really what we're doing is wiring EDM out this part of the gear, and then the shaft's going to fit through it. The shaft's going to be created a little bit later on the manual.
What is it? Is it gonna be like a press fit part, or what are you doing?
For this one specifically,
It's the D shaft.
yeah, so the idea is to have it be may not necessarily press fit, but close enough to where that D shaft will work. We can actually engage the gear. Can I answer your question?
That's the D shape right next to it on the left there. We're gonna use that for pretty much all the D.
So you're gonna take the round stock and you're gonna mill a flat on one side,
Yeah,
Correct.
and then it's gonna be the same shape as the D that you're putting in the center of your gears.
Right.
Yep.
So that you slide that through. So when you described how the fit was gonna be, I think you need to be more precise.
Yeah.
So you could say it's going to be a light press fit, which I think is what you meant.
Yeah.
Right? You want it to not move on its own. So you want it to be slight interference. And you can actually go to the machinery's handbook and you can figure out what the tolerances are and what the dimensions are that you need to have in order to have that light press fit. Because if it's a running sliding fit, then your gear's going to slide across the shaft, and you're going to need to have something that holds it in place. That could be a set screw that goes into it. It could be a shaft collar that goes next to it that keeps it from sliding. You could put a groove in the shaft and put a snap ring on either side of it. So there's many different ways to keep that gear from sliding on the shaft. If you did a light press fit, then it probably won't slide on the shaft until it does.
Yeah.
and it will never not slide on the shaft.
Right. So that's I think that's what you were getting at with the question, right? Yeah. It's not really a design class, but it's something the manufacturer should notice when they're making the part. That's like, hey, I know they didn't tell us what they plan to do here, but maybe they should consider how this gear is going to stay in place from side to side. You could just tack weld it, right? Something like that. That was your original idea, had been to weld it on the shaft, right?
Yeah.
So it's totally a reasonable process, especially after it starts sliding back and forth.
Yeah.
It's just go put a little spot of weld on there. It'll hold it in place. It's really intended to transmit torque. It's not intended to see side loads, but with all kinds of instabilities and stuff, you could see side loads. Since I don't think you're going to be standing on this and pumping the handle up and down rigorously, probably a little bit of super glue would make it get through for the final assembly.
Yeah. We also kind of just wanted to use more machine operation,
Yeah.
so getting to
I think you're good.
Yeah. Our idea with it was just basically using central stock, fixturing that in place, and then having probably just an end mill come down.
Yeah.
And then cut off about 0.04 or something.
Yeah, that's an absolutely reasonable way to transmit the torque from the gear to the shaft. Often you would then couple that with a set screw that keeps it from sliding on the shaft.
More than likely, our biggest issue there would be making sure that the stock that we choose for, because I think it's about 1/4 inch, 3/8 shaft, make sure that has a high enough tolerance, or the tolerance fit together in a way that is actually going to work. So, yeah. Any other questions?
Anything else? Good day to fly a kite, huh?
Yeah.
Group 4, I guess, right? We're flying through these updates today.
I was trying to get to 15 minutes.
I think you made it.
Do you have 2 two-factor authentication? Yeah, we're gonna have to open the recorders. I'll just hit it. I think you're all set, 'cause we don't have any videos or anything.
You want to do the link just below that one? That one.
All right, we are group 4. We're doing the root style supercharger. My name is Nate, and this is Igor. So progress update. This week's progress, we spent a bit of time starting the case on the mini mill and also the VM2 for one of the operations. In SolidWorks, we've added keyways to the gear and the screws. We still have to do some tool paths for that though. Goals for next week, we would like to have this finished. We also want to finally get EDM tool paths and all that stuff done for the gears, as well as tool paths for the screws, which I think are going to be a bit of a challenge. Problems and challenges with such a big group, it is a little bit difficult to find time for everyone to meet. This ended up having a really long operation time. It's about an hour on each side. We had to do it in 2 operations. And we'll talk about this a bit, but the case shifted during the second operation. Nothing broke, but it shifted in the jaws. Assistants and opinions, we would like to talk a little bit about better fixturing for this. Use that moment. So, like I said, we were machining this in 2 operations. The first is the top, as you see it now. I have a photo of that after the first operation on the bottom. That one went well. We didn't really have any issues with that. The issue came when we flipped it over, and as we were clamping on it, we were getting a bit of chatter, and as it was coming around this corner, the end wheel caught it and shifted up in the vise a little bit, so we hit the E-stop and stopped the operation there. But I think we're going to need some better fixturing.
So you didn't
for that.
scrap the part then, because it wasn't the last pass, so you still have plenty of material.
Yeah, there's still material to remove, so this is still usable and this is fine. But we're going to need to relocate it and do all that. I think the issue that we ran into with that is that we were clamping it on this part down here. And I think we ended up having creep in the plastic, which caused it to loosen up as it was going through the operation.
Is the whole 6-inch jaw fit in there, or you put something in between it?
No, we put something in between it.
Okay. I see the marks.
Yeah.
I know exactly what piece you used to put in between it.
Imagine you would. Yeah, so that worked all right for most of it, and then obviously towards the end, I think as it started to loosen up with the plastic deforming, that stopped working. So there were a few things that we were thinking of. One, this piece up top, we were thinking about bolting it down because we do have bolt holes that we were using anyways for the final assembly. The other thing we were thinking about is using the offcut from this and kind of making like a lobed clamp that would fit in here, and we can clamp it sort of typically that way. But we haven't totally made a decision on how we're going to do that yet.
So we were able to finish the wire EDM toolpath on the spree for the gear, but we went back to our CAD models and we made the key shafts, and now we're gonna have to go back and make some changes to the spree before we can actually start machining it. We're hoping we can get this done by next week, considering most of the toolpaths are already made. And the key shaft is just gonna go into you can see it on the next part right here. We also added the key to the shaft. That's going to be on the screw. We don't have too much progress on the screw shaft toolpath yet. We just started it, and we're hoping to have it done for next week so we can actually start turning it. But that's most of what we did for this week. So I don't have any questions.
Anything from the class? You get your piece of plastic there. Yep. All right, so are these threaded?
No,
Were they going to be threaded?
no, they're gonna be clearance.
Okay. All right, so I'm glad that I gave you this piece of plastic to use for your big part, because we get to talk about machining plastic. And so that it could be creep that it moved. It could also just be that there's not a whole lot of surface area here, and what keeps the part from moving is friction, right? And so the friction coefficient between this plastic and the steel of the part is pretty low, which means you got to have more normal force to get more clamping, more resistance to the cutting force. And if you think about it here, if we're holding it right here and we're applying the force over here, we've got a big lever arm too, right? So what are some other ways that we could make this part, or make, you know, what are some other ways we can fixture it or cut the part to make this? Yeah.
You could rotate it 90 degrees and then cut it so that you're cutting those operations from the top down.
So if we held it this way, and we could have left some extra stock, and so we could go all the way around it here, and we could do a 3-axis tool path that makes this shape here, and then this probably would have, well, it wouldn't have moved when you made the whole shape, right? And then you could flip it over and clamp on this part to just make it the right height. That would be a way to do it. I like your idea of bolting it down, with the exception of, I don't know how.
They're not through holes yet.
If they were through holes, I would like the idea better. Then you need to make a fixture plate that goes down here. Then you need fasteners that'll go through it. Oh, it's just because it's the bandsaw cut edge is at the angle. It's an optical illusion. It's not actually bent.
No, it's not.
Yeah. Anything else that the class thinks of? There's two different, right? There's how could you have made it in the first place to make it easier? And then there's what do you do to fix it? So to fix it, you guys are going to use the not quite through holes and make them through?
Yeah.
Make them go through and then hold it down like this. And then is this the finished surface on this edge
that's
anyway?
how it's faced.
Yeah, so that'll work out.
The reason we think it creaked was because it faced it no problem.
Yeah.
We stopped it halfway through the contouring operation to retighten the vise and it moved a significant amount.
Yeah, well, then you can see that you plastically deformed the plastic with clamping the vise, right?
Yep.
Which that won't. Well, since you're not actually going to install this on a motor,
Yeah.
it won't affect the operation of your supercharger.
You can also put that half in the middle so you don't even see it.
Right. So I do like cutting it in this orientation for the surface finish that you get, as
That's why
compared
we did
to cutting it in this orientation for what you'll get from the 3-axis operation. To get something close to this in a 3-axis operation would take a really long time, right?
Yeah.
Did you guys simulate it that way once?
Yes.
You did. Did you look at the cut time that it was going to be?
It was a lot longer.
It was a lot longer, yeah.
And even when we first went to the machine, it in the orientation we have it in, we ran out of memory on a mini mill. So,
Yeah.
It was still a long operation for sure.
So there's ways to get past the memory problem,
yeah.
but like move to a machine with a bigger memory. That's one way. Even with that though, sometimes we run out of memory on the VM2, and so you have to you can't load the code directly on the controller. You either run it from the USB drive and it brings a little bit of code at a time. I call it drip feeding, or you load it into. There's a hard drive on the machine too, so you load it into the hard drive and then you drip feed from the hard drive. And that's the thing that you run into in industry a lot is you need more memory than the machine has. So there's ways around that. Is this just a much higher feed rate? The surface is really different between
Different
the two.
tooling.
Different tooling.
Yes. We couldn't find the free.
Well, are you talking about here versus here?
I'm talking about here versus here.
Yeah.
Yeah.
So we were using a 3/8 and no fluid that had the
Extended reach.
yes.
And then what was this tool?
That was a 1/2 inch because we couldn't find.
But it was still extended reach 1/2 inch tool? That shouldn't have. And Did you tell Esprit that it was a 1/2 inch tool? Then it should have. Yeah, I think you had different. You had different spindle speed too, or maybe it was just vibrating a lot because the gears
I think that's what it was.
It sounded like it was.
Yeah, that's probably what it was. So that'll be a good indication. I think also that if you had clamped it here
Yeah, there was just no.
instead of
jaws.
here,
There were no
it might have worked better.
jaws.
The jaws were not wide enough.
Yeah, because then you could. Yeah. All right. I look forward to seeing the finish. Now, how many of these do you need to make? Two. Do you have enough material? Or do you need another
You
piece?
got us one block, and you said you were gonna bring the other one in.
Yep. Okay. I just didn't know if you got the whole thing out of one piece or not.
I'll get you the other piece tomorrow.
Thanks.
Who's next? Group 6, right?
Yeah.
You the new tab.
Oh,
Down on.
oh my
So
bad.
close. It worked. Okay.
Sweet.
It's the
Okay.
video.
But you don't have permission to view the video. So somebody's got to log in.
Yeah.
No, the keystroke captured that I got set up on that computer. I've got everybody's Google accounts.
Okay, so for this week, we were finishing up work in Esprit. We continued machining parts, and last week a challenge we faced was we didn't think we could find stock pieces that were big enough for our larger parts. But we were able to find those. Some challenges from this week was booking time on the machines. Our goals for next week are to have all parts machined and or finished so we can do a little fit test and possibly assemble the puzzle. Some things that we need assistance on are we're having trouble orienting the parts from STL files from previous operations and working with them. And there was a misaligned axis when making part 3, which caused a little damage to a piece.
So for part 1, Nick's working on this one. Basically, he has pretty much all of the cam done. There's a video on the next slide. He's using, hold on. He's going to use the 1/2 inch end mill, the 3/8 end mill, the 1/8 inch end mill for the interior pockets, and also the 3-inch face mill just to face off the top. We ultimately decided that we're just going to live with the rounded pockets and modify the parts that are going to go in it because they're purely just exterior parts that are going to just sit in it. So we're going to modify that part in the SolidWorks in order to make that work. And this is a video of the cam simulation for this part. This is our most complex part.
I like the screen capture.
Yeah, this is
High
high quality screen capture.
Ta-da! Did you use one of those camera stabilizer things when you band over?
I don't know. That's a
It's
question
all
for
hand?
Nick. Part 2, no status updates. We're just waiting to test it with the other parts. That was finished last week. And then part 3 is the part I worked on. The first operation is complete. You can see right there's a couple issues. One is there was a hole that was deeper than I thought it was. So there's going to be a small divot in like the bottom of the part. It shouldn't affect
ability to assemble the puzzle. And also, my y-axis wasn't quite aligned properly with when I machined it, so there's going to be a little notch in the corner. You can see it in the circle. I might machine it again if I have stock and time, but we'll see. And then the right angles were successfully made with the 2 bosses on top. I wasn't sure if they were going to come out right angles, but they did.
This is the shorter of those 2 parts from that.
There's only one that's sort of shaped like this.
Yeah, but there were 2 parts that were in that 3x3 stock that I cut out.
Oh,
yeah, I think this is the shorter of the 2. There's no stock for you.
Okay.
Unless somebody else used it since last week.
Okay, if I want to cut it again.
Yep.
Okay.
And then we have a couple parts that have duplicates, so in the next week, since we already have the files, we already did one of these, we just need to go back in, find another piece of stock and duplicate that.
So part 11, this was one of the ones I worked on that's just ready to be machined. And then part 10, I'm having a little bit of trouble with this one. So this is how, we're gonna have to turn it 3 times. So these are the 3 orientations. So first we're gonna start with the top and then move and turn it on the side and then operate on that and then flip it over. So like that 3rd picture, that's like the bottom is now on the top, and then we're gonna machine that part. The main problem that I'm facing here is making the chains. I think this is something that I might have done, or just like the way my like canvas just set up, but it will not let me make my own chains. And so I've been using the auto chain and that's been working fine. But my current problem is every time I make a chain, it changes the axis that I'm drawing in. And any chain that is not, or any operation made that's not on an auto chain collides with the part. And this is something I've been like working with one of the TAs with, and I can't really figure out what's going on. So if anyone has any suggestions.
Can you go back in 2 slides? Stars for it.
Stars, that was just so I could label which ones were the top. Just because I couldn't orient it correctly.
Oh, the top
For
face.
office use only, right?
Yeah, yeah.
Do you have time this afternoon to go through the problem with orienting the part, this one?
I do not.
No.
I'm getting on a bus at.
How about tomorrow morning?
I'm leaving for 4 days after this for a swim meet. Yes, but I have time on Monday.
Monday will work.
Okay.
Monday, President's Day. Get that.
We don't get enough.
We should be presidential on Monday. I can do pretty much any time after this class. I prefer not to do it at 1 o'clock. So let's, you can use my scheduler. Just put something on my calendar. We'll do about 25 minutes, and we'll use your part and go through an example of the issues you're having and the problems, and then I'll capture it on video and I'll post that so everybody can benefit from going through that. If we had the software here right now, I would just do it right now. But I know exactly what your problem is. I know how to fix it.
Okay, great.
Is there anybody in the class that knows what her problem is? No? This will be a good video then. Everybody will watch it. I'll get lots of YouTube hits.
Perfect.
Perfect. Go viral. Anything else from the class? Any other questions from the class? Any other exciting news from the class? Nothing? Happy birthday to you. Happy birthday, dear Heather. Happy birthday to you.
During one of the group presentations, there was something I said, when we're done, I'm gonna go talk about that. Anybody remember what it was? Nope. Me neither. Didn't write it down. Couldn't be that important.
Machining plastic.
But I got up and talked about machining plastic when we were doing that, so it wasn't that. It was something I was like, oh, we'll talk about this as a group at the end instead of interrupting. So. Room control. Okay, who's got, somebody over here had the WPI calendar open, I just saw it on their computer screen. What's unique about next week, besides President's Day?
We don't have class Thursday or Friday.
Yeah, but we do have class on the holiday.
Big brain.
And this class meets on Thursday or Friday? Which means this is the last Thursday of the term. No, is it?
Okay, one week after, one more.
Right. This is the last Thursday that's not the last Thursday of the term. That's what I meant to say. And that's what I was going to get up and talk about at the end of class, or at the end of the presentations. That means there's no more progress updates before we're done.
No.
Right? That's what it means, right?
Yeah, that's crushing.
It means there's no more progress updates before we're done. And there's only, what, 2 more classes before we're done? Two like lecture classes before we're done, and 1 more final presentation update before we're done. So I mentioned I saw a really funny picture on Facebook, LinkedIn. I don't remember which one it was this morning. It's not usually really funny pictures on LinkedIn, but it could have been. And it might not have been this morning. But it was a group of people that worked at a law firm. And it was like one big fancy law firm or something. And the caption was, we asked them to dress like they dressed when we were on Zoom. And so there's like people with their, suit coat on and their, funky shorts and stuff like that, standing in front of the door to the building of the law firm. I think of that because as we do these presentations, so we've only got 1 more shot of the presentations, right? 1 more shot. And so in this final presentation, use up the allotted time. Definitely use up the allotted time. And look at it as if you were presenting a project you worked on that you're proud of to your potential future employer, right? Because, they'd probably have a hard time finding you with Google, but the stuff's on YouTube now. They could find you, your potential future employer. Like, how seriously do they take these presentations, right? So, and I guess like it's not the whole group that's going to present, right? So the group can decide amongst yourselves who's the best presenter to represent us, right? Who's the person who should represent our group to show the great work that we did, right? Great work. Will have been great work by then. Yes. So the reason I had to do the submit the link to your presentation was so that we wouldn't have to goof around with switching who's logged in and all that stuff after the first week. I was like, yeah, we don't want to do that, right? So before you present, make sure your presentation is going to work with the way we're doing it.
Yeah, I mentioned to you that
there's ways to make it so the video works.
yeah, when you link the video, make sure the actual video in your drive has been shared so that anyone with the link can view or edit it.
Yeah, the other I think I've run into this problem before, and so what I always do is if I'm linking a video, I make sure the video is on YouTube and it's publicly viewable YouTube. You don't have to do that. You don't have to put your stuff up there and make a thing. But there's got to be a way that makes it work through the link. You can test it by creating like an incognito tab and not logging in and seeing if it works. So those things, and I, I'm not I'm giving you feedback. I'm not holding it against you, right? So, but for next Thursday, that's the one? No, the one after. The next Thursday we meet, when we do these final presentations, try to impress me with how cool your presentation is. Not like the fancy animations and stuff, that's bullshit, right? But like how seriously you took the presentation. Talk about lessons learned. Talk about the things you had to learn in order to do the thing, to do your project, right? Because everybody learned different things, right? Not everybody got the same lesson. We're sharing our lessons here, but talk about that as part of your presentation. And does anybody think that any of the groups might have trouble finishing successfully and having a functional thing that actually works? Does anybody think, I mean, I know we don't think our group's going to do that, but does anybody think one of the other groups might be in that position? If you find yourself in that position because, I don't know, hurricane blows in and we lose power for 8 days, probably not a hurricane, but could be a blizzard, right? Right? If you find yourself in that position, then hype the parts of the project that worked, right, in your presentation, right? Talk about what worked, talk about what you learned, and try to use it as like a practice, as if your potential future employer says, give us a 15-minute presentation on a project you did in college. In fact, if I was hiring recent college graduates, that would totally be part of the interview process. Because I want to see how well they communicate. I want to see what they're proud of learning, right? If you're doing that kind of a presentation, you're talking about something you're proud of learning, or something you think is important to the employer. So, yeah. Bedazzle me with how good your presentation is. Doesn't have to have fancy animations. If it does have fancy animations, it better have really high quality content. I hate it when people try to hide poor content with fancy animations. I hate it when I try to hide poor content with fancy animations, especially. So I try, like if I have animations in my presentation, that means I thought the content was pretty good before I went back and bothered to do the animations. Or, yeah, I suppose there's some where I was trying to hide the poor quality content. It's really what's the function of the animation? Like when you put an animation in a presentation, and we've all, raise your hand if you've ever seen an amazing presentation, right? I mean, who's watched more than one TED Talk, right? That means the first TED Talk you saw was pretty good. You watched another one because you were expecting high quality, and that's really what it is, right? Sometimes they use AV, sometimes they use props and things like that, but it's really about conveying information to the audience. And so we've all seen amazing presentations. If we want to do an amazing presentation, why would we put an animation in it? What's the value of the animation in an amazing presentation? I don't know, I'm picking on animations. What?
If it makes something more clear.
If it helps demonstrate clarity, that's one reason to do it. Why else?
To like highlight the importance of something.
To highlight the importance of something. Really, it's to capture the audience's attention, right? And so it's that change of texture thing. It captures the audience's attention. They say they say if you're going to do a presentation like a classroom lecture and stuff like that, believe it or not, I've studied those things. I've read books on it. I've watched seminars on how to be a good speaker and presenter, especially in a classroom situation, because I don't know about you, I hated it when I had the professors that would drone on and do the death by power. Well, we didn't even have PowerPoint. It was death by transparency slides. Right? I hated those. I needed something to be excited about in order to pay attention to the lecture. And I hate it when I'm standing up here and I see this. Right? I mean, sometimes it's because they're tired and have to yawn, but at least you covered your face with a mask before you yawn, right? Perfect timing, thank you. And so I try to be dynamic. Anyway, so you use those tools in order to draw the audience in, to capture the audience's attention. They say you have to have a hook that gets the audience excited within the first minute of your presentation. People like who's heard start off with a joke? Anybody heard that? Don't start off with a joke. Get them to like you and then tell a joke. Also, I mean, that doesn't really apply here, but don't start off with like a 5-minute bio about how cool you are. For one thing, the person who introduced you probably gave a short bio about you. Today, if they really want to find out how cool you are, they're going to Google you anyway, right? So just have cool Googleability if you want them to think you're cool. Yeah, but and in the classroom, every 9 minutes you have to hook the class again. You have to do something that hooks the class every 9 minutes. Otherwise, they will go to sleep. There's a guy that studied this. It's statistically proven. Every 9 minutes you have to have a hook. Something that gets the class excited. Something that I'm going to end here in 2 minutes. But one of these books that I read, I forget the name of the book. Tell to Win, I think is the name of the book. Tell to Win. The guy that is the author of the book, he was president of Columbia Studios when it was bought by Sony, and then he became president of Sony Studios. I think it was Columbia, maybe it was one of those Hollywood studios. And he may or may not have been president when the acquisition happened. But anyway, he was president of Sony when it was or the movie division of Sony in Hollywood for a while, and he did a bunch of stuff. He talks about the fact that you influence people by telling stories, and he talks about in the book. So this is a story I'm telling you guys, right? I'm telling you the story about reading a book. How exciting could it be? So in the book, he tells a story of the best or most memorable lecture he went to in college. And so he studied like cinema or cinematography and film or whatever in college. That's the industry he wanted to work in. And he talks about this professor that comes in, and throughout the lecture, while he's talking on the lecture, he's walking up on the stage, he's undressing. And every few minutes, he'd take a piece of clothing off and lay it on a chair. And he had a couple layers on, I guess. But when at the end of the lecture, he's standing in front of the class on the stage. It's like one of these giant lecture hall things in his boxer shorts. And he explains that he did that so that the students in the class would never forget that lecture. I don't know if you can get away with it today, but you could totally do that back in the 70s. Totally do that back in the 70s. You probably could have gone full Monty back in the 70s. It would have been fine. It was California school too, right? You do anything in California. So anyway, if you want to capture attention, I don't know if I'd recommend the undressing in the job interview, but I suppose it depends on the job. But I think it might be kind of awkward. But it'd be the wrong message to send. But anyways, I've had a lot of fun in the class. We get 2 more content-y lectures. What do you guys want to focus on for those 2 more content-y kind of lectures? Do you want to do another one where we go through Esprit stuff? Yeah. We want to do another one in the machine shop doing some Esprit stuff? Okay, so we have class Monday next week, right? Yes. We do have class Monday next week. Oh, that's when we can go through your thing. We use your thing as an example. You be there? Sweet. Email it to me Monday morning. Yeah.
You should rope some PLAs to come into that lecture so they can help people with individual problems too.
Yeah, they can watch the movie. I'll see what I can do to get some other people in there. Anybody in the class know what her problem is? I mean, the Esprit problem, not in general. Anybody? I know what it is. As soon as she mentioned it, I knew what was happening. Nope, it'll be fun. You got it?
Is it the wireframe issue?
I don't think that, but there could be something to do with that. No, I think it has. I think it has to do with the way you're rotating the part in between operations. So we'll fix that. And the reason I jumped to this conclusion is because I've made the mistake, right? When you're at the machine and I say, oh, this is what you need to do to fix your problem, or you're doing the Esprit and I say, oh, this is what you need to do to fix your problem. It's because I've seen the problem before in front of me. That's how I can so quickly know what the answer is. All right, this has been fun. So 2 weeks from today, final presentations. Use the 15 minutes. Practice so you know it uses the 15 minutes.
How many people?
It's up to the group, but I don't think it should be the whole group unless you want to do like a cameo, where you have people run on stage, run off stage.
Make it really interesting.
Yeah. The content better be really high if you're going to do dynamics like that. Yeah. I mean, did anybody watch the ice dance part of the Olympics? They like figure skating. Yeah, ice dance. Well, no, there's different competitions of figure skating, and one of them is dance. It's like interpretive dance, but on skates.
Is that after the Super Bowl?
I saw it on YouTube before the Super Bowl. Anyway, like go watch. Some of that was amazing, and so if you can do that during your presentation, pretty cool. Like it's like doing ballroom dance on ice skates, in time with the music, and like holding people up in the air and spinning around and stuff. Like, I mean, the guys that do all the jumps and flips and stuff like that. I guess they don't do flips, do they? They do spins. Has anyone did they flip? Ice skating, hockey. Sometimes they flip in hockey, but it's never on purpose. All right, I'll see you guys on Monday in Washburn on Monday.